Assalamualaikum warahmatullahi wabarakatuh, and greetings to everyone, especially for our lecturer, Dr. Prof. Maya, Dr. Hilton Elias Muhammad Hiltubi Ahmad. We are from Group 4, Section 3. My name is Dini Mukafa bin Saudin, matrix number CF240056, and these are our teams, Muhammad Arshad, Muhammad Nasrullah, Abdiwah Ahmed, and Ahmed Mubarak. Today, we wanted to present our presentation about mechanics of material, and the place that we took is at Arcade UTHM. For introductions, structural analysis is a fundamental aspect of civil engineering that ensures the safety, stability, and serviceability of buildings and infrastructure. The aim of this project is to analyze a real-world frame building system by evaluating its structural behavior under various loading conditions. Through structural analysis methods, either manual calculation or computer-based modeling, the internal forces such as bending moments and shear forces are determined.
Okay, I will continue on explaining objective for our projects. There has four objectives. First is identify and calculating various type of loads acting on the structure, such as dead load, life load, and lastly is environmental load. Number two, developing a simplified schematic drawing to represent the structure layout, support types, and member of geometry. Number three is performing structure analysis to determine internal force, including maximum bending moments and shear force. And lastly is computing the maximum bending and shear stress based on the internal force result.
Assalamualaikum. I will explain about the building description. The building that we chose is Arcade UTHM, primary multifunctional commercial and social hub. It is located in University Tan Hussein Al Malaysia campus in Parit Raja, Johor. The purpose and the location of this building is strategically positioned near residential and academic areas. Serve students, staff, and visitors with retail shops, food court, and offices. The structure consists of 2 to 3 story reinforced concrete frame building designed for density usage. The architecture utilizes minimalist modern style and incorporate natural ventilation, lowered windows, and shaded walkways to manage the tropical climate. The layout prioritizes pedestrian flow and comfort through wide staircase, covered corridors, and dedicated parking.
So here, based on the diagram, I have decided to choose size beam 1. The length of the beam is 4 meters, the height of the beam is 0.3 meters, and the width of the beam is 0.2 meters. Based on that beam, there are 3 conditions loads that are given. The first is the dead load. Here, as you can see, the dead load we have 4, which is RC roof slab, equals to 5.0 kN over meter square. Waterproofing, which is 0.4, ceiling and services, which is 0.3, and finishes and M&E allowance is 0.4. The total of the dead load is 6.1 km per meter square. Secondly, the lift load is a non-accessible roof, so the total load is only 0.0 km per meter square. This is because the beams of the top of the roof is used to only services. And then finally we have is a environmental load. There are 2 loads, which is rain and wind load. Both of them are 0.75 and 0.25, equals to 1.05 kN per meter square. So we total up the dead load, lift load, and environmental load. We have is 7.5 kN per meter square. This is because this beam spaces is 2.0 meter, so the total of the UDL that we have we get is 15 kilometers per meter. Firstly, we need to draw a schematic drawing as you can see in the pictures above. After that, we calculate of support at reaction. I choose reactions A equals to 0, so 15 kilometer per meter multiplies by 4 and multiplies 4 over 2, and then the RBY distance is 4 meters equals to 0. That is the equation. And then after that, we got 120 minus RBY 4 equals to 0, and then sum it up. RBY we get is 30 kilonewtons. And then secondly, we need to get the forces at Fy to get the RAY. So we know the RBY is 30 kilonewtons. So what we're going to do is RAY plus RBY, which is 30, minus 15 multiplies by 4 because of the UDL and the distance. So RAY minus 30 equals to 0, and we get RAY equals to 30 kilonewton. After that, we build a SFD and BMD diagram. So for SFD, because it is a uniform distributed load UDL, so the graph will be directly 90 degrees. So the maximum shear for the SFD is 30 kilonewton per meter. And then after that, now we have to draw a BMD diagram. So BMD diagram is just like upwards. So we got the maximum bending for BMD, which is also to 30 kilonewton per meter. After that, we need to get the stress analysis. So based on the pictures above, the B is 0.2, the D is 0.3 meters, and the moments max is 30 kilonewton per meter equals to 30,000 newton per meter, and same goes to Vmax as well. And then C is the middle of the D, which is divided by 0.3 divided by 2 equals to 0.15 meters. So for the formula we use is inertia, I equals to BH cubic over 12. So 0.2 multiplies by 0.3 cubic divided by 12, so we got is 4.5 minus 10 the power of negative 4. After that, we need to sketch a diagram for bending stress distribution. Based on the pictures above, it goes like this. So how do we determine the maximum bending stress? We use the formula MC over I. M equals to our moment, which is 30,000 newtons, multiplies by the C, which is 0.15, divided by the initial that we just got, which is 4.5 multiplied by 10 the power of negative 4. And then the result, the value we get is 10 multiplied by 10 the power of 6 MPa. Then we also need to sketch a diagram for shear stress distribution. How we got the tau max for maximum shear stress? The formula is VQ over IB. Tau max is also we can use is also 1.5 V over A. So for the tau max, 1.5 multiplies by 30,000 newtons, we got up over area, which is 0.3 multiplied by 0.2. And then after that, we just insert the calculations, and then the result we got is 0.75 multiplied by 10 the power of 6 MPa. Last but not least, we need to calculate the deflection maximum of the beam. The formula is given is equals to 5WL the power of 4 divided by 384EL. The 5, and then we insert the 15,000, the unit that we get, and then multiplies by the length of the beam, which is 4, the power of 4, and then divided by 384E. E is given for the beam of the concrete, which is 35 multiplied by 0 the power of 9, and then the L, the inertia, is 4.5 multiplied by 10 the power of negative 4, and then the result we got is 0.004444 meters, and then we convert it into millimeters, which is 4.44 millimeters, which is way lower than 11 millimeters. Why I say way lower than 11 millimeters? Because for me, the strength of the structure of the building is very good, because if let's say the value that we get is exceed 11 millimeters, then the deflection maximums of the beam will, we can see the crack of the beam.
This is image of the beam that I have selected at Arcade UTHM to calculate. Okay, this is the size of the beam that I have choose. For the length of the beam is 4 meters. Height of the beam is 0.33 meters. Width of beam is 0.2 meters. Okay, this is the load calculation for my beam. So the dead load total is 6.1 kilonewton per meter square. Live load total is 0.4 kilonewton per meter square. Environmental load total is 1.0 kilonewton per meter square. So after that, I plus dead load plus live load plus elemental load. So I get 7.5 kilonewton per meter square. So for the beam spacing is 2. So 7.5 kilonewton per meter square, we multiply by 2, and then we get 15 kilonewton per meter square for beam UDL, undistribution load for my beam. Okay, this is psychometric drawing for my beam. It has 15 kilonewton per meter of UDL, undistributed load, and it has reaction on RAY and RBY. So RBY I have get negative 13 kilonewton, and for RAY I have get 13 kilonewton. Okay, this is the shear force diagram and bending moment diagram for my beam. Okay, the maximum shear stress Vmax is 13 kilonewton. For maximum bending moment, Mmax is 13 kilonewton per meter. This is the calculation for stress analysis. My beam is rectangle beam. So the base is 0.18 meter. The depth is 0.33 meter. For the Mmax is 13 kilonewton per meter. We convert to Newton per meter is 13,000 Newton per meter. Vmax 13 kilonewton, we convert to Newton 13,000 Newton. And for C, the depth 0.33 meters, we divide by 2, and then we get the C 0.165 meter. For the initial ISX is 5.39 multiplied by 10 power of negative 4. Okay, this is the bending stress distribution diagram that I have sketched for my beam, and this is maximum bending stress calculations for my beams. The maximum bending stress that I have get is 9.18 multiplied by 10 power of 6 megapascal. Okay, this is the shear stress distribution diagram that I've sketched for my beam, and this is the calculation for shear stress. So the total of shear stress, maximum shear stress that I have get is 0.0757 multiplied by 10 power of 6 megapascal. Okay, this is the calculation for deflection maximum for my beam. So I have get 0.003958 meters. So I convert to millimeters. So I get 3.958 millimeters above of 11 millimeters. So the strength of the structure of the building is very good.
Assalamualaikum. I will explain about the beam tree. So the beam is located near the food court in arcade. So for the load calculation, the dead load, I assume that the roof slab is 5 kilonewton per meter square, the waterproofing zero point 0.4, ceiling and services zero point 0.3, and lastly the finishes and M&E allowance is zero point 0.4. The total of dead load is 6.1 kilonewton per meter square. For the live load, the roof is non-accessible, so I assume for the services and things, the total live load equal to zero point 0.4 kilonewton per meter square. For the environmental load, the rain load I took it as 0.75 and the wind load 0.25. So the total environmental load is 1.05 kilonewton per meter square. Thus, the total load for both for for the load calculation is 15 kilonewton per meter. Assalamualaikum. So, for the calculation on the supported beam, the supported beam, the beam is a simply supported beam. So, the UDL, which is the uniform distribution loads, is 15 kilonewton per meter from the dead load that I calculated previously. So, to calculate the beam for the RB, so that MA is equal to 0, then 15 times 4 times 45 minus RB times 4 is equal to 0. So the RB that I get is negative 30 kilonewton. For the RA, I assume Fy equal to 0. RA plus RB minus 15 times 4 equal to 0. Thus RA equal to 30 kilonewton. So for the shear force diagram, the maximum shear that we get is 13 kilonewton based on the diagram. So as we can see on the diagram, the both A and B pin got 30 kilonewton force acting on it. For the maximum bending that we got on this beam, the formula for the maximum bending Mmax is equal to WL times 2 over 8. So the weight that we get is 15. The length of the beam is 4 times with 2. Then we divide it by 8, so we get 30 kilonewton per meter. For the bending stress analysis, the cross-sectional of the beam is 0.33 meters for the height. For the width is 0.18 meters. And lastly, for the y, which is the cross-sectional length, is 0.165. For the inertia I, the formula is BHQ over 12. Thus, we get 5.39 times 10 power of 3, negative 3 meters power of 4. For the bending stress, formula is My over I. So we put the calculation in that. Thus, we get the bending stress is equal to 9.18 megapascal. For the deflection analysis, the formula is 5 WL power of 4 over 384 EI. So I assume that E is equal to 25 gigapascal as a concrete beam. So the calculations that we get, we got that the max deflections is 3.7 millimeters. We know that the allowed deflections is 11 millimeters, that the max deflection that we get on this beam is 3.7 millimeters. Thus, 3.7 millimeters is less than 11 millimeters. Deflection max is less than deflection allowed. Thus, the strength of this structure of beam is good.
My name is Abdul Wahab Ahmed Yusuf. I would like to present my beam. My beam is beam 4. This is beam 4. The sizing beam 4 information. We have length beam 10 meter, high beam 0.33 meter, and with beam we have 0.18 meter. This is how to calculate how to calculate the supporting beam. First, we have to calculate VB. We get 75 kilonewton up, and we have to calculate VA. We get 75 also up. After that, we have to calculate shear force diagram and then bending moment. The first diagram is free bend diagram. The second one is shear force, and the last one is bending moment. After that, we have to calculate maximum shear. Vx we get 75 kilonewton, and we have to calculate maximum bending max. We get 187.5, and after that we have to calculate tau max. Also tau max we get 2.6085 times 10 negative 4.
Hi, hello everyone. My name is Ahmed Mubarak. My matric number is AF240080. Today we will talking about this beam. This slide show us the structure analysis of simple support beam with a span of 4 meters. As you can watch here, this is the size of beam 5. The information of dimension. The length is 4 meter and the height is 0.30 meter. And width beam is 0.08. Right now we will talking about calculation on the support beam. This calculation have 3 types of support of beam. The first one we will talking about dead load. The dead load we calculate and we find is equal to 6.2 kilonewton meter, and the live load we will calculate also we find 0.4 kilonewton meter, and also we get the environmental load. The first thing, real load is 9.81 multiplied by 0.076 is equal to 0.75 kilonewton meter, and we calculate also wind load is 0.3 kilonewton meter, and also we calculate the total environmental load. So we get 1.05 kilonewton meter. So we calculate all this and we find the total is 7.5 kilonewton meter. And after this, we calculation of the support reaction. So we use some formula to get this calculation of support reaction. We get 22 kilonewton meter, 22 kilonewton, and also for M, and we get for Fy is 22 kilonewton. It's the same thing. You can watch here in the shear force diagram. We get the Vmax 22 kilonewton. And also for bending moment diagram we get 22 kilonewton. We're using some formula to get this number. And after this we're talking about deflection analysis example. In this part of this analysis, check of deflection of the beam, which means how much the beam bends under the applied of support. The first thing we will calculate the moment of inertia. We're using some formula to get the number, and for I we get 9 times 10 over minus 3 m over 4. And after this we calculate the maximum deflation. We're using some formula and we get the last number is 1.63 times 10 over minus 7 meter, and this is the maximum for the deflection.
My name is Abdullah Ahmed Yusuf. Discussion. This project allows students to apply structural analysis theory and real frame structure by analyzing load, internal force, stress, and deflection. Students gain a clear understanding for structure behavior and stability overall. The project strengthened practical knowledge and bridges to gap between theory and real engineering application.
In conclusion, this project helps us understand how structural analysis is applied in a real engineering structures. By analyzing a real format system, we learn how different loads act on structure and how they affect shear force and bending moment and deflection. This project also allowed us to connect theoretical concept with practical calculation in diagram, Overall, it import our understanding of structure behavior and show the importance of paper design to ensure safety and stable in real world structure. And thank you.
Before we end our presentation for our project for today, I just wanted to say that we all are very grateful and a warm thank you to Dr. Hilton for giving us the platform and the opportunity for us to present our project presentation, and also during lecture classes. Dr. Hilton has helped many of us a lot in terms of knowledge and learning about mechanics of material. I wish Dr. good health, and I think we will see you soon. So, Assalamualaikum and selamat syatukel kepada semua. Thank you.